So, let's go. 3 mega-tsunamis in 2 years. A magnetic field that nearly died and took complex life with it. And the crisis 600 million years ago, that might be the only reason you exist. None of it made the news. Let's fix that. Number 1. The wave nobody saw coming. On August 10th, 2025, at 5:30 in the morning, a mountain fell into the ocean. Not metaphorically, not a little bit of a mountain. 100 million cubic meters of rock, the whole face of a cliff above the South Sawyer Glacier near Juneau, Alaska, just let go. And when it hit the water, it took 57 million cubic meters of glacier with it. Everything went in at once. The wave that came out was 470 to 500 meters tall. Let that breathe for a second. The Eiffel Tower is 330 meters. This wave was taller than the Eiffel Tower by 150 meters. One World Trade Center, the tallest building in the Western Hemisphere, is 541 meters. The wave was almost exactly that tall. A building-sized wall of water moving through a fjord in Alaska at 5:30 in the morning, and the only thing that noticed was a seismometer that logged it as a minor earthquake. After traveling 5.6 kilometers, roughly the length of 56 football fields, it hit a nearby island. At that point, it was still 30 meters high. That's a 10-story building still. After all that distance, every tree on that island was gone. On the ground, house-sized chunks of rock had been picked up and thrown hundreds of meters. Soil stripped down to bare stone. Vegetation erased in a clean horizontal line up the fjord walls like someone drew it with a ruler. 0 casualties. Some kayak equipment on a harbor got swept away. That was it. Nobody was there. Nobody saw it. The only reason we know it happened is because a seismic detector registered something weird and scientists went looking. This is the second tallest mega-tsunami ever recorded in human history. It happened 7 months ago. And you probably didn't hear about it, but here's the thing. It's not a freak event. It's the third one in 2 years. And that's where this gets uncomfortable. Number 2, what a mega-tsunami actually is. Before we go further, you need to know that what just happened in Alaska is not the kind of tsunami you learned about in school. The tsunamis that cross oceans and flatten coastlines, those are tectonic. A plate slips, the seafloor lurches, and an enormous amount of water gets displaced across an entire ocean basin. Those waves rarely exceed 30 meters, even at their worst. A mega-tsunami is different at every level. No earthquake required, no tectonic plates. What you need is a large amount of solid material, rock, ice, dirt, or some combination, hitting a body of water all at once. Not gradually, all at once. What you get is less a wave and more a splash. An incomprehensibly large splash. One that can reach hundreds of meters in height right at the impact point before it starts to die down. There's no official scientific definition for mega-tsunami. Scientists just use the term for waves that exceed roughly 100 meters. The physics are real, the name is informal. The results are not. The record holder is the 1958 Lituya Bay event, also in Alaska, also in a fjord, also triggered by a landslide. This one shaken loose by a magnitude 7.8 earthquake. The wave reached just over 500 meters. It stripped trees from a hillside more than half a kilometer up. If you stood at sea level and looked at where the tree line got erased, you'd be craning your neck back at roughly the angle you'd use to look at a skyscraper. People survived it. 3 fishing boats were in the bay. 2 rode the wave and made it out. 1 didn't. The destruction marks from 1958 are still visible today. 67 years later, you can still see exactly where the water went. That was supposed to be a once-in-a-century event. Then, September 2023 happened, then summer 2024, then August 2025. Number 3, 3 in 2 years. In September 2023, a massive landslide collapsed into Dixon Fjord in Greenland and generated a mega-tsunami. In the summer of 2024, another landslide hit the Takini River in Yukon, Canada, and then Alaska in 2025. 3 events, 3 different countries, all in the Arctic or just below it. All caused by the same thing. When a slope has been frozen for thousands of years, permafrost, glacial ice packed into the cracks and joints of a mountain, that ice is structural. It's holding the rock together. When it melts, the mountain loses its skeleton. Slopes that were stable for millennia become slopes that are waiting for a trigger. A warm summer, a heavy rain, sometimes nothing at all. They just go. Permafrost covers about 25% of the northern hemisphere's land surface. Most of that is warming faster than anywhere else on Earth. The number of slopes that are structurally compromised right now, sitting above fjords, sitting above rivers, sitting above the ocean, it's not a small number. All three of these events hit remote locations. Uninhabited fjords, no towns, no ports, no people. The same wave in a Norwegian fjord or on the coast of British Columbia would be a different story entirely. The pattern is real. The cause is strongly implied by everything we know about what's happening to Arctic permafrost, even if the direct scientific link needs more pinning down. 3 events in 2 years after the previous record stood for 67 years is not a coincidence that needs a lot of explaining. But the wave isn't the scariest part. The scariest part is what happens after. Number 4. The bathtub effect. When the 2023 Greenland mega-tsunami hit Dixon Fjord, seismometers around the world started picking up a strange signal. Rhythmic. Repeating. Every few minutes a pulse. Over and over again. Scientists had no idea what they were looking at. It took weeks of post-event analysis to figure it out. The fjord was sloshing. Here's what happens. A mega-tsunami hits a fjord. A long, narrow, enclosed body of water. And the wave doesn't just crash and dissipate. It bounces. It hits the far wall and comes back. Hits the near wall and goes again. Back and forth, back and forth. Like water in a bathtub after a toddler punches it. Except the bathtub is kilometers long and the waves are enormous. This is called a seiche. It's a known phenomenon in harbors and lakes, usually caused by wind or atmospheric pressure. But a mega-tsunami generating a seiche in a fjord, that had never been confirmed before until Greenland 2023. That seiche lasted 9 days. For 9 days, Dixon Fjord was oscillating, large waves repeatedly slamming back and forth across its entire length. Any boat in that fjord, any person on its shores, for 9 days after the initial wave. And the whole thing was detectable as a rhythmic seismic signal from anywhere on the planet. The Alaska seiche in 2025 lasted 34 hours, still nearly a day and a half of the fjord violently sloshing, still potentially enormous waves, still dangerous. Nobody knows why Greenland lasted 9 days and Alaska lasted 34 hours. Fjord geometry maybe, water depth, volume of material, it's unresolved. Scientists are still working it out. What they do know is that a mega-tsunami doesn't end when the wave ends. The fjord keeps going. A new phenomenon, confirmed for the first time in 2023, is now showing up at every event, and we only just noticed it exists. Something about that should probably worry us more than it does. Number 5. 600 million years ago, Earth almost died. Now, we leave the fjords. We leave Alaska and Greenland and the 21st century entirely. We need to go back 600 million years because something happened to this planet that makes mega-tsunamis look like a splash in a puddle. Earth's magnetic field almost went out, not weakened a little. Not dipped temporarily like it's doing today, very slowly, in a way scientists monitor but don't panic about. This was something else. During the Ediacaran period, roughly 600 to 800 million years ago, the magnetic field dropped to the lowest level ever recorded in Earth's geological history. And it didn't just get weak, it got chaotic. Today, when the magnetic field reverses, when north becomes south, it takes hundreds of thousands of years. The poles wander gradually. It's slow enough that life barely notices. During the Ediacaran, it was happening in thousands of years. The field was lurching, spiking, and crashing. Reversing and reversing again before the previous reversal had even finished, completely erratic, like a generator that's about to fail and is throwing the lights into a strobe before it dies. A 2025 study pulled this out of volcanic rocks in Morocco. Rocks that locked in a magnetic record when they cooled, preserving exactly what the field was doing at that moment. What they found confirmed the chaos. The field during this period was unlike anything else in Earth's known history, and the reason it was failing comes down to something that didn't exist yet deep inside the planet. Keep the geodynamo mechanics simple here. Earth's magnetic field is generated by liquid iron in the outer core, churning around a solid inner core. The solid core matters. It provides a surface for that convection to work efficiently. It also releases heat as it grows, which keeps the whole engine running. 600 million years ago, the solid inner core didn't exist. The whole interior was liquid. The geodynamo was running on fumes, no stable surface, no extra heat, just a churning ball of molten iron slowly losing energy. The field it was producing was getting weaker and more erratic by the million year. And at some point during the Ediacaran, it came close enough to full collapse that scientists describe it as showing signs of potential failure. What came after this line is where the science tips into hypothesis. The facts above are established. What follows is a compelling and very recent explanation for what the weak field actually did. But it's still being tested. Number 6. What saved the field? Around 600 million years ago, deep inside the Earth, iron started to freeze. Not the way ice forms in a tray in your freezer. At the pressures and temperatures at the center of the planet, the iron in the liquid core eventually reaches a point where it transitions from liquid to solid, crystallizes, and that crystallization releases heat. Latent heat. The same physics as water turning to ice, just scaled up to planetary proportions and happening over millions of years. This process is called nucleation. And when it started, it changed everything. The new solid core, small at first, growing slowly, gave the convection in the outer core something stable to work around. The heat being released from the crystallization fed energy back into the system. The geodynamo, which had been failing, got a new power source. The field strengthened, the chaos stopped, the magnetic shield recovered. The solid inner core today is roughly the size of Pluto. About 1,220 kilometers across, suspended at the center of the Earth, still growing. It adds to itself constantly. It has been crystallizing for the last 600 million years, and it is not done. The timing is the thing that should stop you. The magnetic field was at its absolute weakest exactly when the first complex life was beginning to diversify in Earth's oceans. The recovery happened right at the boundary before the most important evolutionary event in the history of the planet. A few hundred million years earlier or later, and none of what follows happens the same way. But here's the part nobody expected. The weak field, while it lasted, may not have just threatened life. It may have fed it. Number 7. The crisis that built us. A weak magnetic field means a weaker magnetosphere. A weaker magnetosphere means less shielding from solar wind. And solar wind, when it hits the upper atmosphere, strips away the lightest gases, mostly hydrogen. You can watch this happening in real time, not here, on Mars. Mars lost its magnetic field about 3.5 to 4 billion years ago. Its core cooled too fast, convection stopped, the field died. Solar wind has been stripping its atmosphere ever since. NASA's MAVEN spacecraft has been sitting in Mars orbit measuring the rate of hydrogen escape directly. It's ongoing, steady, relentless. The Mars we see now, thin atmosphere, no liquid water, dead surface, is what happens when a planet loses its magnetic field and no one saves it. During the Ediacaran, Earth was heading toward the same outcome, but the timing of the inner core's crystallization interrupted the process before it went terminal. And in the tens of millions of years that the field was weak, before the save, something strange was accumulating. When hydrogen escapes the atmosphere, it takes itself out of circulation. Hydrogen that's gone can't bond with oxygen, can't form water vapor, can't do the chemical work it normally does. And so oxygen, instead of being swept up into other reactions, starts to build up in the atmosphere, in the surface ocean. Slowly, over millions of years, the oxygen level rises. For small, simple life, this doesn't matter much. But for larger, more complex animals, things with organs, with active movement, with bodies that need to be continuously supplied, oxygen is the limiting factor. You can't build a brain without a lot of oxygen. You can't build muscle. You can't build anything complicated. The hypothesis that came out in 2025 is this. The Ediacaran magnetic anomaly caused sustained hydrogen loss, which drove a slow oxygenation spike, which crossed a threshold that made complex animal life biochemically possible for the first time. Then came the Cambrian explosion. Starting around 538 million years ago, nearly every major animal body plan that exists today appears in the fossil record within a geologically tiny window. Shells, eyes, limbs, nervous systems. All of it suddenly, like evolution, hit fast forward. There were other factors. Cyanobacteria producing oxygen, tectonic shifts changing ocean chemistry, the thaw after snowball Earth releasing nutrients. The magnetic anomaly hypothesis doesn't replace those. It adds another piece, a mechanism that nobody had connected before. But it's new science. It's being tested. It is not settled. What it suggests, if it holds, is that the near death of Earth's magnetic shield is one of the reasons complex life exists. That the slow failure of the geodynamo over millions of years quietly oxygenated the ocean just enough. That the crisis was the precondition. That you are here, in part, because 600 million years ago, Earth's core almost gave up. Number 8. The creatures that lived through it. While all of this was happening, while the field was failing, while hydrogen was bleeding away, while oxygen was slowly rising, something was alive in Earth's oceans. They weren't animals. Not really. Not in any way you'd recognize. Dickinsonia looked like a leaf. Flat, oval, ribbed up to 1.5 meters long, no mouth, no gut, no obvious front or back. It moved somehow, left traces, then stopped leaving traces. Charnia looked like a fern frond growing from the seafloor, also with no clear biological category it fits into. There were disc-shaped things, quilted fractal things. Organisms that appear in the fossil record with no ancestors and no obvious descendants, like they arrived from somewhere else and then quietly ceased to exist. These are the Ediacaran organisms. They lived during the magnetic anomaly. They existed in the oxygenating oceans. They were the first complex multicellular life to get any kind of foothold on this planet. And then, at or just before the Cambrian boundary, they vanished. Every one of them, replaced entirely by Cambrian animals. The first creatures with shells and eyes and bilateral symmetry and all the body plans that eventually led to fish. And then amphibians, and then you. We don't know why the Ediacarans disappeared. Competition from Cambrian newcomers is one explanation. The changing ocean chemistry is another. Maybe the window that opened for them, the specific oxygen levels, the specific conditions, simply closed. The magnetic field recovered, the oxygen dynamics shifted, and the organisms that were built for that narrow window didn't survive outside it. One reading of all of this, the magnetic crisis opened a door. Strange life walked through. The door closed. And on the other side were us. Number 9, Mars, is the warning. Mars didn't get lucky. The southern highlands of Mars contain ancient, heavily magnetized rock, remnants of a global magnetic field that once wrapped the entire planet, just like Earth's. That field generated by a liquid iron core, convecting, doing the same work Earth's core does. For a while, early in the solar system, Mars had an ocean. It had an atmosphere thick enough to hold liquid water on the surface. It had conditions that, for a window of time, were not entirely unlike early Earth. Then the core cooled. Mars is smaller than Earth, at about half the diameter, and smaller planets lose heat faster. The liquid iron in the core stopped convecting. The geodynamo stopped. The magnetic field died probably around 3.5 to 4 billion years ago while Earth's was still running. What followed was slow and total. Solar wind reached the upper atmosphere without anything stopping it. Hydrogen stripped away. The atmosphere thinned. Water couldn't stay liquid on the surface. The oceans evaporated or froze. The planet dried out from the top down over hundreds of millions of years until the Mars we see now is what was left. Maven is watching it happen in real time. Not fast, the atmosphere is already thin enough that the stripping is more of a slow bleed than a hemorrhage. But it hasn't stopped. Mars is still losing atmosphere, still losing hydrogen. The process Earth narrowly interrupted during the Ediacaran is still running uninterrupted on the planet next door. Venus is the other version. A planet roughly Earth's size, close enough to have developed similarly, now wrapped in a crushing carbon dioxide atmosphere hot enough to melt lead, with no liquid water, no detectable life, and clouds of sulfuric acid. Whether Venus lost its magnetic field early and took the Mars path, or whether something else drove it to the greenhouse extreme, is still being worked out. Either way, it ended up somewhere nothing survives. Earth threaded the needle between both of them. Same solar system, same general starting conditions. And the difference, at least in part, comes down to a solid ball of iron the size of Pluto, crystallizing at exactly the right time, in the dark at the center of the planet 600 million years ago. Number 10. Crisis is the engine. So here's where we are. In the last 2 years, 3 mega-tsunamis have hit the Arctic in quick succession, driven by ice and permafrost that's been structurally failing as the planet warms. A phenomenon that's supposed to be rare enough that the previous record stood for 67 years has now happened 3 times. In every case, those waves generated a kind of oscillation that we didn't even know existed until 2023. A sloshing that continues for hours or days after the initial wave, detectable from anywhere on Earth, still not fully understood. And 600 million years ago, Earth's magnetic field failed slowly enough that it accidentally oxygenated the planet, which accidentally made complex life possible, which accidentally led, through hundreds of millions of years of evolution, to animals with eyes, then fish, then land creatures, then mammals, then something that eventually looked up at the sky and asked what was out there. Both threads point at the same uncomfortable idea. Earth is not stable. It never has been. It runs on near misses and narrow windows and timing that had no reason to go right, but happened to. The mega-tsunamis aren't a bug in the system. They're the system expressing itself under new pressure. The Ediacaran crisis wasn't a threat to life. It was the setup for the most important biological event in the history of the planet. Every catastrophe we know about left something behind. The ones we haven't had yet will too. The wave that stripped a fjord clean in Alaska at 5:30 in the morning left nothing standing and nobody hurt. The field that nearly collapsed 600 million years ago left us. The creatures that lived through the chaos and then disappeared left their oxygen, their ecological vacancy, their hard-won biological innovations for something else to build on. Earth doesn't just survive its crises, sometimes it needs them.